Hi, this is Adrian Duke. Um, so here's my lab. So I follow the state diagram, and so I have everything coming in here. So I have A0 as my input, and then A1 and A2 coming in from the flip-flops, which have also read and writes in them. Reads in them. And yeah, and so Y0 comes out, it's inverted, goes back into the flip-flop, and then Y2 and Y4 come out into this NAND and come back in here and go into the flip-flop. So that should be it in terms of the wiring. If you actually look at it, so let me reset it. So starting from a state where X is on high, what should happen according to the flow chart is, so right now we're on a state of 0, 0, which is A. So if I put X on 1 and then I reset it, nothing should happen. And I clock it, nothing should happen. But if X goes down to low and I clock it, now we're in state B. So now we're in state B, and so from state B, if I put it on 1 and I clock it, it should go back to state A. So if I clock it, state A. And then from state A, let's go back to B. So now we're in B, and then if I keep it on 0, now we're gonna go to state C. So if I clock it, now we're in state C. And then state C, keep it on 0, it doesn't matter because if you clock it, nothing will happen. Second. Clock it, nothing will happen. But if you put your input back on high, so A0 goes back on high, and clock it, original state A. Yep. Hello, so this is Adrian. So my input's on 0, and then 1 is my clock, and 2 is my reset. So my input comes into 0, 1 on the decoder, or A0 on the decoder, and then my outputs of the decoder, so Y1 and Y3 NAND together, and then it's inverted using a NAND, whatever that output is, and then that's NANDed with my Y5, I believe. Is it Y5? Yes, it's Y5. And that's NANDed with Y5, and that goes into my flip-flop, which comes back and reinserts. And then my other side for my other side of the flip-flop has just one single NAND between Y7 and Y3, which is the same one we used earlier, so I had a yellow cable. And that goes into the flip-flop, and both of these flip-flops are directly, or these A1s and A2s. So both of these, that's great. So both of these flip-flops go into our reading positions. So if I demonstrate it now, let me just reset it. So power it off, and then reset. And so now I have I'm in the original state with nothing there, in A. And so in A, if I put a 0, then it should stay 0. In A, if I put a 1, it should go to B, which it does. If I'm in B, I can give it a 0 to go back to A, and it does. So now I have to go back to B. So I'm back at B, and then I put a 1 in there to go to D, which should be 1, 1. Now it is 1, 1. And then at D, I can use a 1 and go to C. And then from C, I can use a 0 and go back to A. And that's working